So, as you guys should have already been working, I asked you guys to do 2 of these. I asked you guys to do the orbital diagram for carbon and the electron configuration for cobalt. So what I'm going to do is I'm going to bounce over to the periodic table, and then so carbon is number 6. So what we're going to do is, again, we've got carbon. So no matter what element, what do you always start with? 1s. Okay, and this is the orbital diagram, so it's arrows. How many arrows fit in that orbital? 2. One's up, and the other is down. Being honest, how many of you did the half arrows? I told you. Okay. All right, what's next? What's after 1s? 2s. Very good. How many you got? 2. Up and down. And then, so that's hydrogen and helium, that's lithium and beryllium, and finally we're in the energy level we need. And again, this is just a curiosity question. I don't care. How many of you use the brackets for the P block? Do y'all like that? Does it really help? If it does, awesome. If it doesn't, you do what you do. Like, I just want you to do it however you can do it that works. So P is how many orbitals? 3. 1, 2, 3. Remember, if you're going to sell a house, make sure you claim all your rooms. Okay? Then, we only need how many arrows? 2. Now, tell me, if you were grading this, if you were the teacher and you saw a student have this, that is wrong. What do you do to correct it? Okay, I'm going to come back, and I'm going to make them go up, up. Real quick, I should have left it up there. Well, actually, I can go back real quick. If it were like this, and I'm telling you, you're going to see some questions like this, whose rule would this have broken? This is Hund's rule. Remember, you separate your kids before you double them up. This is Hund's rule. All right, any questions there? All right, very good. So let's go to the next one. Let's go to cobalt. This time we're doing the electron configuration. Okay, so cobalt is way down here at 27. So here's the good news today. Let me go ahead and foreshadow where we're going. Do you agree that this is a fairly long electron configuration? What I'm going to show you today is what we call the noble gas configuration, which is a modified, shortened version, which is just as effective. But before I can teach you that version, you got to be able to do the whole thing. Okay, so let's look at the full electron configuration. Again, no matter where you're starting with, what's the first energy level? Okay, 1s, and how many are you going to have? 2. What's after 1s? Okay, so that's hydrogen, helium. All right, we've got 2s. We're going to use both of those, so that's 2s2. What's after 2s? 2p. All right, are you going to use all 6? Yep, that takes care of all of those. Do y'all like seeing it on the periodic table? Does that help? Okay, good deal. So after 2p, we've come down to sodium, which is what? 3s. I'm going to use both of those, so let's get rid of this. Come over to 13. What is that? 3p. I'm going to use all 6 of those, get rid of that. Then we've got the next one is 4s2. Get rid of those. And again, this is the part where I want to make sure I stop and make an emphatic part of this. What row does it look like the D block begins on? It looks like 4, but what do we know about the D block value? It's 1 up, or one less, if you want to think about it from that perspective. So it's 3D, and then what number? 1, 2, 3, 4, 5, 6, 7. Everybody good with that? Okay. If complete where were you going with that? The other way, and that's why I wanted you to do this. Okay. Complete hypothetics. If I asked you to do this in the orbital diagram, I only want to look at the last one, the very last orbital the last part of it. How many lines would you need in a D? You would need 5. 1, 2, 3, 4, 5. So this is 3D. And then what would your arrows look like? Okay, it would be up, 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 up. And then what do I do? Okay, down and down. Everybody good with that? Okay, just if you had to do the orbital diagram, that's what the last one would look like. Yes, sir. Say that one more time. To be 100% honest with you, I'm not quite sure why it's only one value. Like I said, I could spend a whole hour explaining to you why there's a difference in energy levels, but that has well beyond the need to know reason. So it's much easier for me to say, just know it's one less, and let's move on. Okay? And I want to make it simple as possible, and that's all you need to know. Sarah? 4s. Yes. So D is actually a little less than 4s, but you fill 4s first. Just, I don't want to go there. All right. To be honest with you, I think the other part of this, the other parts of these worksheets, let's talk about platinum and plutonium. So let me tell you why I would not ask you guys to do platinum or plutonium. Platinum is right here. Very good. What block would you have to go through to get to 78? You'd have to go through the F block because 58 through 71 is a part of that. So we're not going to worry about going to plutonium. What's after plutonium? Excuse me, platinum. Wait, hold on. On the platinum is PT, plutonium is PU, which is 94. So that's actually in the F block. So we're not going to do that. And then you guys, what am I doing? I keep hitting the wrong buttons. Oxygen and potassium. I'm not even going to worry about oxygen. You guys know how to do that. So the last one we're going to do, which is the first time you guys are going to see the noble gas configuration, we're going to do potassium. And you guys are going to love potassium. So, no, this is legit. You're going to love doing, you're not going to love potassium. You're going to love the noble gas configuration, okay? So, here's what the noble gas configuration is. Hold that thought. Yes. Let me figure out the best way to write it so it's the most effective and efficient. All right, so write that down on your sheet of paper. Again, I wouldn't write it if you're. I would write this on your sheet of paper. So the noble gas configuration. This is what you do. You put the noble gas that is previous. That is the key word. The noble gas configuration. You use the noble gas that is previous to that needed element. Okay. And which element are we doing in this example? Potassium. So hold that thought. Just keep this in mind. So we need the noble gas that is previous to potassium. Oh, I forgot to put what it in. Put the noble gas to the previous to the needed element, and this is where the part that I forgot right here. In brackets. Can't believe I forgot that part. That's the most important part. Shut up. So, put the noble gas previous to the needed element in brackets and complete the electron configuration. And I promise it'll make sense whenever you see it. Put the noble gas previous to the element, to the needed element in brackets and complete the electron configuration. Yes. It's not. It's the noble gas before potassium. No, I mean, you can do any of them this way. I promise it'll make sense. I'm not going to leave you hanging. I'm going to show you an example. Burn. We have this conversation daily. How many people come in 7th period? It's like 8 or 9 of them. It's a grind. It is a grind. All right, so let's look at what we do. So again, we're working with potassium. So what it said to do was take the noble gas previous to the needed element. So if potassium is number 19, first of all, where are the noble gases? Okay, this group right here. Okay? So, if potassium is 19, which noble gas is previous to 19? Argon. And what do you put it in? Brackets. All right, so stay with me. This will make sense. Do you agree that we are looking for potassium? That's the one we're working with. Okay? So we're going to put argon in brackets. So now, whenever you see this in a book, some books and some worksheets don't show this, but let me encourage you why I want you to do this. And this is just something very simple. What is the number of argon? I always like to write it right there inside the brackets, and it will make sense as soon as you see why. That tells me I know that argon is 18. Now, then the next thing you do is complete the electron configuration. So guess what's cool? This entire bracket with the noble gas in it takes up 4, 1s2, 2s2, 2p6, 3s2, and 3p6. So instead of writing all of this, you can write that, and it takes the place of it. Okay? So the next thing you do is just complete it as usual. So you start back here, and what's the next thing that you're going to write? Try again. 4s1, and that's it. Okay? This is all you have to do for noble gas. Now, yes, this is a lot easier, but if I had never shown you the long version, this would not have been as exciting to you. You would have just said, okay, that's the way we always do it. But again, the noble gas configuration can be simplified in using the noble gas and the brackets, and then it takes the place of all this other junk. So if I ask you to come down here and do this one right here, do you really have to write all of that mess? No, okay? Well, I'm just saying, hypothetically, okay? Now, let me go back and explain the reason of why I want you to do what I begin with. Why did I ask you guys to put that number there? Very good. Say that one more time. Very good. Remember that double check method of how you can tell if your numbers are right? So if you know that argon is 18, 18 plus 1 makes what? Which is what you wanted, 19. Yes, sir. Holt, yeah, let's just do some examples, okay? But let's do that one together. Okay? I just don't want to get too far ahead. Okay? So here's the one I want you guys to do next. I want you to do the noble gas configuration for zirconium. Oh, hang on, Teddy. Hang on. Zirconium. Before we do this, again, we're doing ZR. What is the noble gas previous to the number 40? KR, krypton. Not the closest. The previous. And because, Skylar, I'm going to give you an example. Hold that. We'll come back to it. Okay. Of why you can't do that. Okay? All right. Everybody good? We're doing zirconium. Hang on. We're trying to find the noble gas configuration of krypton. Okay? So we found the previous noble gas is krypton, and what comes after number 36? Rubidium, which is number 37. So what is the electron configuration starting here? 5s. Am I going to use both of those? Yep. Be very careful here. What's the next value? 4d. And what is it? 4d2. That's it. That's it. No. This is very important distinction. I'm telling you now, you're going to see all three versions. You're going to see an orbital diagram, which is the arrows. You're going to see electron configuration, which is all of it. Then you will see a few of these noble gas configurations. And I'm telling you, even if you get it right, if you do the wrong version, that's not what I'm looking for. I'm making sure you can do all three versions. Okay? All right. Now, Skylar, to answer any questions on this one. Teddy, you had a question? Okay. Skylar, to make your point, here's the one I want. Here's the one I want to do. I want to do fluorine. Okay. So here's what Skylar said, and I'm not trying to say that she's wrong, but I want to make this a point. She said you used the closest noble gas. According to that theory, what's the closest noble gas? Argon. But you can't use that because chlorine has 17. How many does argon have? Well, that defeats the purpose. You've already gone past it. No. Okay. So what do you have to use? The previous one, which is neon. Very good. So let's do chlorine. So chlorine is going to be Ne, which is 10. Okay. So that takes care of all of that. We've used every bit of that. So now let's come in and start with number 11. What is number 11? Okay, 3S. We're going to use both of those. Okay, then let's go over to 13. What's 13? 3P and how many? 5. Yes, ma'am. No, because I'm not grading them. I've got too much to do to grade them. All right. Let me tell you this. The more you do, the better your grade's going to be. And just all those worksheets that I gave you for practice, the more you do it, then the better your grade's going to be. So, now, last two things on this topic. AJ, we'll come back to yours in just a second. Let me go ahead and kind of tell you something. What if, how do I want to do this? What if I asked you specifically for xenon? If I ask you for a noble gas, can you just put it in brackets and be done? No. Okay. I know that's going to upset you, so you have to go back to Krypton and do it out like you regularly would. So if you are asked, don't ask me why. I don't make the rules. I'm following them. Okay. If you're asked for a noble gas, you still have to use the previous noble gas. Okay. So go ahead. It is 5, which block? P is in pillow. And then what number in the pillow? Six. So we've got KR, and then after number 36 is 37. So 1, 2, 3, 4, 5. Okay, thank you. So we've got 36 here. So the next thing we have is number 37, which is going to be 5S2. And be very careful what comes after 5S. 4D, 4D10, and then that's all of these. And then after 4D10 is what? Very good. 5P6. Go ahead. I mean, sure. I don't have anything against it. No, you can't do that. It has to be a clean periodic table when you start the test. No, because I don't feel like dealing with it. All right, so last thing, AJ, to go all the way back to your question. I want you guys by yourself. Okay, so let me explain why the noble gas was even invented. Is for these really big ones. It's not really poignant to do it for these smaller ones, but when you get out here and you've got 101 of them, like, that's when the noble gas is effective. Okay, so you don't have to do the whole thing. All right, so we've got nickel. All right, I'm good. So what's the previous noble gas to nickel? Okay, so we've got AR, which is 18. And then after AR is 19, and that's going to be 4S2. And then that takes care of those. And then getting in here, we've got 3D, and it should be 8. Now, let me tell you something. if you were to look this up online on Wikipedia or any of those, if you're doing those worksheets this weekend and you're checking your answers, let me tell you something that you may see, and I don't want you to freak out. Here's what, and Eli and I have already established this, right, Eli? Okay. When you see some of these things in a Wikipedia or online, what they'll do in the noble gas configuration is they will swap those two. Can someone tell me why that might be? That's exactly right. 3 technically is less than 4. So in the noble gas version, they will flip them. I don't believe that's accurate. I think that that's misleading. So this is the version. But if you do it the other way, I'm not going to be angry because I get it. I understand it. I will be able to figure out what you're trying to do. But if you look up some of those answers and they have the D before the 4, the 3D before the 4S, that is why. It has to do with just the value. Don't worry about it. Just follow along as we've kind of been going. But I just want you to be forewarned of that. All right. Any questions? Go ahead. We're not. I'm not even going to show you. Nope. We're stopping at 56. All right. So there's one other thing. So here's what I'm going to do. I'm going to give you guys a few minutes to do. Here's what I want you to do. 1 and 2. Do 7, 7. All right. Do me a favor. Flip that sheet of paper over and put stars by the following ones. 1 and 2. Just flip it over. Oh, did I change them already? All right, just can I see yours real quick? Because I want to see the changes. All right, here's what I want you to do. This is important. Do 1 and 2, 6 and 7, 11 through 15. Those are easy. All you have to do is tell me what. Just write the symbol. 1 and 2, 6 and 7, and then 11 through 15, and stop. Now, here's the deal. Look at the instructions for 1 and 2. It says write the unabbreviated. That means the whole thing. Okay, the long way. Okay, the expanded version. Number 2 says write the abbreviated. That is another way of saying the noble gas. Okay, so get practice on doing 1 and 2, 6 and 7, and then 11 through 15, and then I'm going to come around and help you out if you have any questions, and then we'll answer them. Okay, so here's what I want to do. I'm going to show you guys something that I think is a concept-driven idea that you really need to kind of grasp, because it's going to lead into stuff that we're going to do later on. I'm pretty confident in 1 and 2, and I'm pretty sure you guys got number 6. 6 would have been XE in brackets and 6S1. That's what you would have had. But here's what I want to show you guys. I want to show you something that would lead to what we call an ion. And I think visually, it'll make complete sense. I'm still debating on it. Probably not. Okay. All right, so the one I want you to do, and it's going to be a completely different version than you guys did, but I want you to see it anyways. Actually, I'm going to do it with fluorine, because fluorine is a lot easier to do. So I'm going to do the orbital diagram of fluorine. Okay, no matter what, where do you always start with? 1s, so up, down. What's after 1s? 2s is what? Up, down, and then now I'm in 2p. Can I shorten this? Sure. I mean, there is something called the noble gas orbital diagram. Same concept. Okay. All right. So here's the deal. Fluorine is number 5 in this, right? Okay. So we've got 1, 2, 3, 4, 5. Now, somebody tell me about the location of fluorine and its significance to its orbital diagram. I know that's a large stretch, but can someone kind of just tell me what you see visually? Okay. It has one open spot. Go ahead. Would you? All right, so let's think about this. If I added 1, do you agree it's already got 9? So if I come in and I add 1, who would it look like? What do we know about that entire group? So if something is stable, do things like stability? Do atoms like stability? So the entire purpose of this and the concept of the ion using the orbital diagrams is for you to visibly see why the fluorine would want to gain how many electrons? 1. Does that make sense? So this would represent something that you could be able to see what fluorine would look like. So if we come in and add this, fluorine is now full. Fluorine is now stable. But here's the important part. Is fluorine still just F? Why is it F negative? You gained a what? What's the charge of an electron? Negative. Does that make sense? So if I were to ask you to do the noble gas or the electron configuration or orbital diagram of that thing, what must you do? Add an electron. Okay? Let's look at the alternative version. Let's look at sodium. 1s up down. Oh, I don't like all this. Okay. Alright, so 1s up down. 2s up down. 1, 2, 3. 2p. That hurt. Oh, that was gross. Sorry, the pen squeaked. Yes. The pen was like nails on a chalkboard. Oh, that just made my spine tingle. Okay. All right, so let's look at this. What do you notice about sodium? Okay, it's got 1 hanging out in the S block. If we could come in and we could lose this thing, who would it look like? Well, if it's got 11 and you lost 1, who's it now look like? Looks like neon. Do you agree that if we lost that one, everything's now full? Okay, so sodium would turn into Na what? Plus. Yes, ma'am. All right, that's the concept, is that it is an ion. It's the sodium ion. And here's why it's still sodium. All of these numbers that are on here, 1 through 118, what did they represent specifically? That number is the atomic number. Do you agree? The atomic number is also equal to what specifically? Protons. The number of protons defines an atom. This thing we're losing or gaining is a what? An electron. So the center of this thing, the nucleus, still has 11 protons. So who does it still have to be? It still must be sodium. But its charge is different because you gained or lost an electron. So it can still maintain its identity of who it is. And this is going to be very gruesome, but stay with me. If I take Teddy and I rip his arm off, okay, is Teddy still Teddy? He's just lost an appendage, right? Okay, so sodium is still sodium. It's just lost an appendage. That's a weird way to think about it, but it makes sense. Okay. Now, and this is where it gets real fun, Teddy. Okay. What if I take magnesium? Okay. 1s, up, down, 2s, up, down. I'm just going to say 2p and all that junk. Okay. Then we've got 3s, up and down. So this is magnesium. We've got 12. Now, I know that that's full, right? This whole thing is full. However, if we lost those 2, it goes from 12 to who? 10. So if I take both of Teddy's arms, he's still Teddy. He's still magnesium. But it's now Mg what? 2 plus. Well, you still got 2 legs. Say that again. Don't worry about this. I'm not going to test you on this. But what I'm showing you is, and I'm going to tell on one of the worksheets.
The worksheet that looks like this, it has this on the front, and stuff. On the, oh my God. No, I promise I don't. Yeah. All right, so on the back of this, a few of them have the charger, which it would be without this. But I'm not going to test it with the bread. Well, remember, so real quick, make sure you work through those worksheets. Make sure you watch the review video. If you have issues, you got to let me know before Sunday at 10 o'clock. Because I'm not checking my email after like 8 o'clock. So if you need to start tonight, tomorrow, or early on Sunday if you've got some problems. I've already reshared all the videos. Yes, ma'am. Okay. Yeah, and that's why I didn't want to get into it, but visually I wanted you to understand of how it compares. Okay, Raylan? Yeah. By the way, yeah, let me give that to you. I know we're running out of time, but I want to give everybody back everything.